Okay, so today we're going to work on 8A.2. I'll get him in just a minute. Okay, so for unit 8A.2, we are going to graph exponential functions. Graph exponential functions. Okay, the way to graph exponential functions is we are first going to complete the table of values. Complete the table of values and graph. Okay, complete the table of values and graph. So for example number 1, if I give you the equation y equals 6 to the x power, y equals 6 to the x. So table of values means we're always just going to do a little xy table. Key thing to remember is you always want to plug in numbers for whatever letter is in the exponent. So here, would we want to be plugging in for x or y? For x. Okay, we're going to plug in whatever letter is in the exponent. So you're always going to plug in -2, -1, 0, 1, and 2. And that's just because with exponential graphs, you can tend to get really, really large answers. So you definitely want to see a little bit on the left, a little bit on the right, and right in the middle. Okay, so these are just the standard numbers that we're almost always going to plug in. So if you plug this in, 6 to the -2 power gives you what? What is 6 to the -2? Becomes 1 over 6 squared, which is 1 over 36. Okay, how about 6 to the -1 power? 1 over 6. Okay, 6 to the 0 power equals 1. Anything to the 0 power equals 1. 6 to the first equals 6. 6 squared is 36. Okay, so now that we've plugged in our values, now we just need to make a graph. So you're just going to make a real simple graph. Okay, on the x-axis, how many dash marks should we make on each side? How wide does this graph need to be? 36 is a y value, so that's an up and down. 2, okay? You don't need to do a bunch of dash marks on the side to side. We're only going from -2 to +2. So -2 to +2. So don't worry about making a bunch of crazy dash marks. Then, excuse me, when we actually graph this, -2 up 1 over 36. So left 2 up 1 over 36. So it's almost touching the x-axis, but not quite. Okay, then -1 up 1/6, so it's, again, almost touching the x-axis, but not quite. It's a little bit higher up. Then 0, 1, okay, that one's a definite point, so I want you to actually, make sure you put a little line there. Over 1 up 6. Now, do I really expect that you're going to put 6 dashes? Not really. Okay, but let's just assume it's higher up. And over 2 up 36 is like crazy high. So it's way up there. I do not expect that you're going to put 36 little dash marks. Okay, in fact, I don't want you to. That would be a giant waste of time. Then, once you have all these, connect them with a smooth line. Now, when you connect on the left side, you need to be very, very, very careful. Okay, because this graph will never, okay, I repeat, never touch the x-axis. Okay, this graph will never touch the x-axis. Graph will never touch the x-axis. So if it never touches the x-axis, what does that mean? What's it called when something touches the x-axis? It makes an x what? Intercept. So since it will never touch the x-axis, there will be no x-intercepts. Okay, so just keep that in mind. There are never going to be x-intercepts on an exponential graph, ever, unless you do something wrong. Okay, this graph will never touch the x-axis. Okay, another really important point here is 0, 1. Okay, this is, what is this called right here? What's it called where it touches the y-axis? The y-intercept. Okay, the y-intercept is at 0, 1. Okay, and it's actually really important that you realize that because every exponential graph has the same y-intercept. Every exponential graph has the same y-intercept. And the reason that happens is because no matter what you have for your base, anything to the 0 power equals 1. So anytime you put a 0 in as the exponent, it's always going to give you a 1. So no matter what you plug in for your base, your graph is always going to have the point 0, 1. Now, what would you call this type of graph? Do you think, does it look like it is increasing or decreasing? Increasing or decreasing? Which one? This is an increasing. Okay, this is an increasing graph. This is increasing, or something we would call exponential growth. Okay, increasing or exponential growth. Okay, so we will do word problems a little later in this unit. I think it's actually on Friday. And this is an example of something like bacteria. Okay, they grow exponentially. Or have any of you guys heard about the like that measles outbreak that started at Disneyland? Okay, that's exponential growth. Like it started with 1 person, and then all of a sudden there was 8, and then all of a sudden there was like 60. Okay, that's exponential growth. That's an example of exponential growth. Okay, next graph we're gonna do is for number 2. I'd like you to graph y equals 1/6 to the x. Y equals 1/6 to the x exponent. So we're going to start the exact same way. I'm going to start with an xy table. What letter would I want to plug in for here? The x or the y? We always plug into whatever's in the exponent place. So this is the x. So again, we're going to start by plugging in -2, -1, 0, 1, and 2. And it doesn't matter if you start with the negatives or with the positives. It really doesn't matter either way. So 1/6 to the -2 power. What does that do? -2 power flips it over, right? So -6, excuse me, x 1/6 to the -2 power actually gives you 6 squared, which is what? 36. Okay, it flips it over. How about 1/6 to the -1 power? +6. 1/6 to the 0 power. 1. Okay, so anytime you plug in 0 for the exponent, you're always going to get the 1. So this is that same y-intercept always. Then 1/6 to the +1 is 1/6, and 1/6 squared is 1/36. Okay, then we're just going to make a fairly simple graph. Again, how wide does this graph need to be? 2. Okay, you don't need to make it super wide. So if we graph these, okay, if you start graphing this at -2 up 36, so that's like way off this graph, you're not even going to see it basically. -1 up 6, over 0 up 1, always going to have that same y-intercept, over 1 up 1/6, and over 2, 1/36. So this one is going to be exactly inverse of the first one. So it's getting really, really close to the x-axis, but again, it will never touch. Okay, it's never going to touch the x-axis. It gets really, really close, but it does not actually touch. Ever. Notice again that this one has the same y-intercept. So it has a y-intercept at 0, 1. Now, what would you say this graph is doing? Is it increasing or decreasing? This is decreasing. Or this is something called an exponential decay growth, or decay graph, excuse me. Decreasing or exponential decay. Okay, you'll see this a lot of times with like half-lives of something. Okay, so like a radioactive element or something like that, it has a half-life, it becomes less radioactive as time passes. Okay, questions so far? Yes. Because it's going down. The values are getting smaller. Whereas this one, the output, the y's are getting larger. This one, they're getting smaller and smaller. Don't think of decreasing as being negative, but think of them as being smaller and smaller. They're never going to get negative, but they will get smaller and smaller. Okay? Number 3. Example 3. This one's a little bit more challenging. Okay? This is going to be one of the more challenging things that we'll do for this unit. If I tell you y equals 4 to the x, if y equals 4 to the x is graphed. If y equals 4 to the x is graphed. Which value of x produces a point closest to the x-axis? Y equals 4 to the x is graphed. Which value of x produces a point closest to the x-axis? And I'm going to give you a multiple choice basically here. So would 1, 0, -2, or 1/4 produce a point closest to the x-axis? So the way we do this is you basically need to plug things in. Okay, so you're going to make just a little XY table. What am I plugging in for the x's? These numbers. 1, 0, -2, and 1/4. And we're actually going to graph these and see which one gives you a value that's closest to the x-axis. So if I plug this in, 4 to the first gives me 4. 4 to the 0 is equal to 1. What's 4 to the -2? 1/16. What's 4 to the 1/4 power? We don't actually know that, okay, but you can write it in power handle. So this is the 4th root of 4. Do we know what multiplied by itself 4 times gives you 4? No, we don't know, okay? But what we do know is we could graph this, okay? If we graphed this at -1, or excuse me, at +1, this is at 4. Okay, so over 1 up 4. At 0, it's at 1. At -2, it's at 1/16, so it's way down here. At 1/4, where would this be? It doesn't have to be perfectly exact. We just know it's going to be somewhere in between these 2 points. Okay, I don't really care where it is. It's just somewhere in between them. So don't get caught up on figuring out exactly where it is. Okay, so if I drew this, which value of x produces a point closest to the x-axis? Which is the x-axis? The up and down or side to side? The side to side. So which one is closest? This one. Okay, the -2 produces a point closest to the x-axis. Okay, -2 produces a point closest to the x-axis. So just graph them and then look. Now, I don't know if you guys remember, but when you first learned how to graph, okay, like the y equals mx plus b graphs, we used to make you do these, table of values, okay, and you hated it. And then all of a sudden we taught you y equals mx plus b. And you thought, well, why didn't you just teach me that from the beginning? Okay, exponential function graphs are kind of similar like that, okay? The general rule, general exponential function graphs. General exponential function graphs. Okay? There is a general rule that basically tells you anytime you have a y equals a number to the x, okay? Y equals a whole number to the x. Anytime you have a y equals a whole number to the x. Based on example 1 and example 3, what do you think they're going to look like? Look at the whole number graphs. What do they both have in common? They're both doing what? Look at the ones that we just did. They're both increasing, okay? What else, what other special point do they have always? 0, 1. Every exponential function graph has to have a point at 0, 1. Okay, so as long as you include that point, and any whole number graph, based on what we just did, we can say is increasing. Okay, so it starts really low, starts getting really, really close here, and then exponentially increases. Okay, that is a pattern. So from now on, you don't have to do these table of values. If I ask you to make a rough sketch of any whole number to the x, as long as it's exponentially increasing and includes the point 0, 1, that's it. I don't need perfect graphs. I just want to know that whole numbers are increasing and include the point 0, 1. Okay, the only other kind that you really have to know is anytime you have a y equals fraction to the x. Okay, so anytime you have a number over number or a fraction to the x exponent. Based on number 2, what do you know about a fraction graph? It always includes what point? 0, 1. Every exponential function graph includes 0, 1. And exponential functions that are fractions, are they increasing or decreasing? Decreasing. Okay, so as long as you follow that general rule, exponential fraction graphs are decreasing, whole number graphs are increasing. The way I remember it is that fractions are falling. Okay, the fractions are falling down. So it's like you're going down a slide. Okay, fractions are falling, whole numbers are increasing. So basically, no matter what I asked you, okay, so if I gave you something like, we'll do another one here for number 4. If y equals 1/2 to the x is graphed. Y equals 1/2 to the x is graphed. Which value of x produces a point closest to the x-axis? You no longer are going to have to actually plug these in. Okay? If I gave you, let's say, which value of x produces a point closest to the x-axis, and I give you -2, 0, 1, or 5/2. Which value of x produces a point closest to the x-axis? The only part that you really have to memorize about these is these graphs, these two, the general rule. Okay? As a general rule, a fraction graph is going to do what? Jalen, is it increasing or decreasing? Decreasing. So if you know this general rule, the value of x that produces a point closest to the x-axis is which one? Is it the most positive or the most negative? Is it the most positive or most negative points where it's getting closer? These are the most positive, right? So as it gets more and more positive, this line gets closer and closer and closer. So which of these would produce a point closest to the x-axis? Definitely not -2, right? Definitely not 0. Which one? 1 or 5/2? 5/2. Why is 5/2? Because it's more positive. Okay, 5/2 is like 2.5. It's bigger, it's more positive than 1. Okay, so make sure that you know the difference between those. Okay, I also want you to write yourself a note that with exponential functions graphs, you can never have the base be 0, 1, or negative. Okay? On your homework, you are going to skip the questions that ask about that. But just know that on exponential function graphs, you can never have the base be a 0, a 1, or a negative. Okay? Fairly important rule that you memorize. Other than that, you guys have 15 homework questions. And that's it. If you get done in time, let me know, and I will stamp it for you. Other than that, 15 questions, and I will probably collect again on block day.